Hello! It's time to start our new adventure, Pre-Calcuteers. We are in the year 16 on January the 4th in the evening or late afternoon, and we are going to leave our trig behind, but not far behind, because I will practice some trig equations and problems from time to time to keep it fresh. As we dive back into the algebra, we're going to start with a topic of matrices. However, today you will see not one matrix. Not one matrix. No matrices today, because I need to stand on this procedure that I'm going to show you today in order to work with the matrices tomorrow. So let's look at how you would solve a system of equations. I'm going to skip the kind when there's just two equations and two unknowns, where you solve it by elimination or substitution. Assuming you come to me with that skill, we're going to go ahead and look at three equations and three unknowns. Notice this this has x, y, and z, this has x, y, and z, this has x. I'm just going to fill in for ease of operation, just putting in a 0 where there is no variable. Now we will look at this type of system. We're going to solve it by using Gaussian elimination, and Gauss is the mathematician who came up with this. So he is immortalized with the name Gaussian elimination. To understand Gaussian elimination, let me tell you what we're aiming for. Whereas an equation with two unknowns, x and y, that's a line. When you have three unknowns, x, y, and z, you have three dimensions. So here we have a plane, it intersects another plane, and intersects another plane, and we want to know where they intersect. So this one's going to intersect at one point, and it's going to be presented at the end as an ordered triplet, where we have the x-coordinate, the y-coordinate, and the z-coordinate. So if you recall, three-dimensional plane, like here used to be the x and the y plane, and then I'm going to take that, it's standing up, and I'm going to push it down on the ground. So I'm going to, where it's kind of standing up front, I'm going to lay it down on the ground, and with perspective it's going to kind of look like this, x and y. So it's sort of like on your kitchen floor now. I'll put in your linoleum squares. So does that look like it's flat on the ground? Hopefully. Let me zoom in here. Oops. Alright, so I've laid this XY plane that used to stand upright like this. I've pushed it over and it's laying on your kitchen floor now. So the point 2 over and 3 up, 2, 3, will now be 2 over, 1, 2, and 3 up. 2 over and 1, 2, 3 up. 2, 3. And when I add that third coordinate, say I add a 4, 2, 3, 4, that means I go over 2 and on the x direction, go 3 in the y direction, and then I come up out of the floor in the z direction. So I'll say 1, 2, 3, 4, z. So that's the z-axis is coming up out of the floor. So that's how we get the three dimensions. So the point 2, 3 is really going to be 2, 3, 0. And then when I come up out of the floor, it's 2, 3, 4. Alright, just so you have an idea that we're working in three dimensions now, and that these expressions represent planes that intersect. And we're going to look for one point where they intersect at x, y, z, separated by the commas. Alright, to use Gaussian elimination, there are three possible operations. We'll call them elementary row operations. You can take any two equations in our list and exchange their places. So equation 1 and 2 can be, if we call this equation 1, equation 2, equation 3, and we can exchange equation 1 with equation 2. Just they can change places, or 1 and 3 or 2 and 3. So that's one thing that we're allowed to do. Another thing we can do is multiply an equation by a constant. As long as the constant is not 0, we have an equivalent equation. And the third one is multiply one of the equations by a constant and add it to another equation. So this is all we're allowed to do for Gaussian elimination. So I will solve this by using Gaussian elimination. And I'd like to have a check on your notes, so if you don't have your comp book, please write it on another piece of paper. Alright, to use Gaussian elimination, we are going to put these three equations into row echelon form. I have no idea if you've heard of this before, but I'll pretend you have it. Row echelon form. And what that looks like, it's easier to show you than to tell you what it looks like. So the first step to approach row echelon form is to make sure that the lead coefficient in the first equation is a 1. As you can see, it is not. So which row operation can I use to change that 2 to a 1? I can divide everything by 2. So I'm going to actually ask you to write down what you did in order to get the new equation. So down here, I'm going to take row 1, and I'll call it by rows. They're really equations. I'll just call it row 1, 2, and 3. So row 1, I'm dividing by 2. So this one is going to change, so I'm going to point an arrow at it. If you would do that, it would help me grade your work. So down here, I'm going to write what results. Notice equation or row 2 and 3 are not changed at all, so I'm just going to write those in before I operate on the first equation or row. So having not changed anything, notice I put a little tag there on my Z just so you can see it's not a 2. Alright, so this equation 1, I'm going to divide everything in it by 2. So this becomes x, this becomes minus 1/2 y when you divide it by 2, this becomes 1/2 z, and this becomes 3/2, dividing everything by 2. And I have accomplished my first goal, is to create the lead coefficient is now a 1, so I'm happy with that. The next goal in reaching row echelon form is to have every term underneath that first term, which you've caused the lead coefficient to be 1, everything under it, all the x terms under it, to be 0. So the first one I'm going to aim at is this one. So let me get the circle off of here. We already dealt with that. So we are going to change that to a 0. This lead coefficient is 1. I want this whole thing to be a 0. To do that, I'm going to use the first row, and I'm going to multiply the first row by a -1 and add it to the second row. So I'm going to put an arrow on the actual equation that will change. We only change one equation at a time, so I will rewrite the first and the third unaltered. X minus 1/2 y plus 1/2 z equals 3/2, and the bottom 3x plus 0y minus z equals 0. So what does this one become when I multiply the first equation by a -1 and add it to the second? And I will write the result here. Well, -1 times 1x minus, -1 times x is minus x plus x gives me the 0 that I wanted. So I'm just not going to write anything here. There is no more term. So over here I'm going to multiply -1 times -1/2, and I get a positive 1/2. And when I add that to the coefficient here with a unwritten 1y, I get 3/2 y. negative 1 times this term is negative 1/2 plus 1z. Negative 1/2 plus 1 is 1/2 z. And the constant also has to be multiplied by a minus 1 and add it to that. When you multiply 3/2 by a minus 1 and add it to the 6, you come out with 9/2. All right, now we are approaching row echelon form, and we are not there yet. So you get that equation. Now that I multiplied this row or this equation up here by negative 1 and added it to this, this is what result. Why did I choose negative 1 times row 1? Because I wanted to zero out this term. See if you can now, and to approach row echelon form, I have to get zeros underneath this x in all equations. So now I have to make this 0. I'm going to use this to do it. So what will I multiply this first equation and add it to the third so that this becomes 0? Hopefully you get the strategy. It's going to be minus 3 times the first row, minus 3 times row 1, add it to row 3. Will that not change this to a 0? Because we have x here. Minus 3x plus 3x gives you 0. So now we have to do the same for the rest. Excuse me. All right. We know that this is the row that's going to change when we do this operation. So I'm just going to write the first two unaltered so I don't lose anything or forget what I was doing. Takes a little bit of concentration to stay on track. Yep, there's my timer. All right. I'm going to set that again. I'm going to turn this video off and finish the problem on part 2.